all here. I can't believe that I've got as many folks here on the last session of the last day of Summit after the pub crawl. Yeah. Everyone's like, have a beer, and I'm like, no, you don't want that, I promise. All right, good morning, everybody. I'm showing that it is 11 o'clock, and I think that's the start time, right? Yeah. Right, 11 o'clock? All right, cool. My name is Thomas Cameron. I'm the Chief Architect for the Canada region and the Central region in the United States. As you can see, I got kind of an alphabet soup behind the name, so I've been doing this for a little while. I'm fairly familiar with using Red Hat Enterprise Linux and clustering. To my right, we've got Lon Hohberger. He is the supervisor of the software engineering team, which is responsible for doing all of the clustering. Came from an engineering background, super sharp guy. I've bugged Lon for years when we're doing field implementations. So there's a pretty good chance that if you have questions, we're going to have the answer for it. If not, certainly we will find it for you. Again, I do want to say thank you very much for being here. I know this is the last session of the last hour of sessions for Summit, so thank you very much for being here. My contact info is up there. It's fairly easy to reach me. I am thomas@redhat.com. So I've been here for a little while. You can also catch me on IRC as Choirboy, and I'm on Twitter, and there's some websites up there that I've got contact info at. You can reach Lon at lhh@redhat.com, and he's got a page on the Fedora People website, and he's also Lon on Freenode with IRC as well. So today, what we're going to be talking about is Red Hat and clustering, talk about the architecture of the cluster I used to build this presentation, and we'll talk about the steps. We're going to go step by step how I configured the cluster. So we're going to talk about setting up iSCSI both on the target or server and the initiator or client. I'm going to show you how to set up a highly available web server. So we'll install the web server software on all the nodes. I'll show you how to connect to the web management UI. We will define the cluster, create the clustered file system, and I'll talk a little bit about some tips and tricks around clustered file systems. We're going to define the fence device, add hosts to the fence device ports, define failover domains, and I'll explain what those are. Define the resources which will make up the clustered service. Then we will define the clustered service, and I'll take you through testing some of the failover capabilities for the service itself and for individual hosts. So about Red Hat and clustering, we lead the way in open source clustering. We acquired a company called Sistina for about $31 million back in 2004. That included what we refer to as the Global File System and Cluster Suite. Those have changed names now to what we call the Scalable File System and High Availability. We made the source code open source in about the middle of 2004. That is what we do at Red Hat. If there is proprietary software that we acquire, we do our very best to make it open source as quickly as possible. So now, like I said, it's called Resilient Storage, which is our clustered file system, GFS2, and our high availability product, which is the HA Application Services technologies as layered products. So as far as architecture goes, I built this presentation on a 3-node cluster. Essentially, the management node is a machine called lady3jane.tc.redhat.com. It runs the cluster management web interface. It happens to be, but this is not a requirement of the cluster, I used the same machine that I use as the management console as an iSCSI target. That is not necessary or not required for the web server or for the cluster. It's just how I happened to put it all together. So don't be confused. Don't think you have to have an iSCSI target on your management console. We're only using it for demonstration purposes. Like I said, it has 2 gigabit Ethernet NICs. when I installed it, I made sure that I installed the HA management package group and the network storage server package group. And basically, I know this is an eye chart, and I'm sorry, this projector is really bad, but essentially, very, very simple installation. All I have is base, HA management, and the network storage server packages in the Kickstart. So very, very simple installation. The 3 cluster nodes are Neuromancer, Fin, and Armitage. They are connecting using iSCSI in a multipath configuration over plain old gigabit, 2 gigabit NICs. And I installed these with the iSCSI storage client package group, storage availability tools, high availability, and resilient storage. And again, I did a very simple installation. You can see my installation groups, really, really straightforward, really, really simple. And so this is just a graphical representation. I've got my management node up at the top. I've got Armitage, Fin, and Neuromancer. Those are going to be cluster nodes, and I'm using multipath over 2 Ethernet NICs. I did not do NIC bonding. I did multipath, and there's a method of the madness, and I'll talk about that in a little while. So the end result is we want to have a highly available application. In this case, it's Apache, but you can use any one of our applications, any of the services that have System 5 init scripts that'll do start, stop, restart, status, and reload. And that is everything that we ship. So whether it's MySQL or Apache or whatever. So it'll have a floating IP address so that it can move from one physical machine to the other, and the site will use a GFS2 formatted file system, which is concurrently accessible read-write by all 3 nodes of the cluster. So again, verify when you're setting up the iSCSI target, you want to verify that the storage server group is installed. Again, this was done by Kickstart. If you didn't do it at Kickstart, if you just have a real simple machine, you can do yum group install. And I just wanted to make sure that the network storage server group was installed. On the machine which is going to be your storage server, again, in this case it happens to be the management console or the management server, but it doesn't matter. Create a partition. However you want to do that, whether you use parted or fdisk or whatever. And what I did was I took my disk. I only had the 3 partitions for root and boot and the swap, and I added a partition in. I used the rest of my disk. I have a machine in the lab that's got a fairly large disk. So once I created it, I rebooted, and now I've got a large partition. It's not allocated to anything yet. I've just got a large partition that's available. Again, whether you're using an appliance like a NetApp or a RHEL box, doesn't matter. You just need an iSCSI target. So what I did then was, since I'm using RHEL as my iSCSI target, I edited the targets.conf file under etc tgtd, and I just added one stanza that says, I defined my iSCSI qualified name, IQN, the name of it, and the way that I did it was I used the date, the domain name, the host name, and then I just called it storage. I defined my backing store, so the thing that I'm going to be sharing via iSCSI is /dev/SDA4. Then what I did was I made sure that the target daemon was on, so check config tgtd on and restart the service. And it'll say it's not running, so that failed is normal because it's not on. The failed is normal. It restarts, and then to make sure that I am actually sharing that disk via iSCSI, I run the command tgt admin or target admin. The low-level device is iSCSI, so -LLD iSCSI, node target or mode target. In other words, I'm making this query against the targets, and the operation --op show. And I'll get a response that looks like this. It comes back and it tells me, okay, this is what I'm sharing, and this is the one I care about. The LUN is LUN1. It's got, it shows me the size of it, and it'll show me that, yes, indeed, I am exporting. The backing store path is /dev/SDA4. So at this point, I've set the machine up to be an iSCSI target. It's sharing its file system. Now what I need to do is I need to connect the clients, the nodes in the cluster, to this shared storage. And the way that I do that is I just, again, make sure that the iSCSI storage client, storage availability tools, HA and resilient storage RPM groups are installed. What I did was a real quick yum group list, made sure that they were indeed in there, so I know that I'm good to go. You want to make sure that the iSCSI and iSCSI-D services are check configured on. So I did check config --list pipe grep iSCSI, and sure enough, in run level 3, which is what I'm booting, they're on, so I know I'm in good shape. Now what I need to do is, from each one of the nodes that's going to be connecting, each one of the iSCSI initiators that's going to be connecting to the target, I just need to discover the paths. or I need to discover the storage. And I need to do it on both of the paths. And like I said, I didn't use bonded Ethernet, I used multipath. The multipathing software is kind of smarter about figuring out which network interface it's going to send traffic down, so you're going to get better performance out of using multipath as opposed to using bonded Ethernet. The way that I did that was I used iSCSI Atom in the discovery mode, so -m discovery. The type of query I'm doing is send me the targets that you have available, and the portal -p is the IP address or host name that I'm going to be connecting to. So I run it across the first network interface, and you'll notice 172.31.100, so it's on the 100 subnet. And it comes back and it says, oh, okay, here's the LUN that's available. I then run the same query on the other path. So I do 172.31.101.10. So I got one path on the 100 subnet, one path on the 101 subnet, and it comes back and it actually gives me, obviously, the same target name. So now each one of the clients has found the path, or found the storage that's being presented to it. Now that I've discovered it and figured out what that iSCSI qualified name is, I need to then log in. That is going to make that storage actually available. The first step was, what do you have? The second step is, please let me use it. Okay? So I run the command, iSCSI Atom -m node. The target name is that iSCSI qualified name that I just gave you, and the portal is the .100 network interface. -L says log in. And I log in and it comes back and it says, yep, login was successful. You now have access to this partition, this LUN. And then I do the same thing on the second subnet, and sure enough, it comes back and says my login is successful. So each one of the cluster nodes has connected to a single LUN via two different paths. Now, because we've got multiple paths on each one of these clients, on each one of these initiators, we need to define the multipath connection. So you want to make sure, obviously, that you've got the multipath D RPM installed. And what we're going to do is, you'll notice that initially I look for the multipath.conf file. It's not there. So you can automatically generate a multipath conf file by running empath conf enable. I like to use user-friendly names. I would rather have a human-readable name than some giant WWID. So I said multipath or empath conf enable, user-friendly names, yes. Find multipaths, yes. Load the kernel module, so with module equals y, with the multipath D service turned on, yes, and then with check config, yes. Basically, if you tell it to do all the work for you, it'll load the kernel module, it'll check config the multipath D service on, it will start the multipath D service, and it will generate your multipath.conf file. So where before we didn't find one, now if I look at the multipath.conf file, it's built the file for me. Sets my defaults, it's find multipaths yes, user-friendly names yes, no devices are blacklisted, so my machine now has multipath enabled. So, again, I like to, additionally, in the multipath.conf, I like to set the boot paths to, both paths to enabled, so I say path grouping policy multibus. That's actually a default setting, but I like to have that on. What that's saying is use both paths concurrently, as opposed to maybe a failover type situation. I prefer to send the next I.O. based on how free a path is, so I set the path selector to service time 0. What that'll do is that'll actually, there's a heuristic there that says which path is least busy. Okay, use that one. That's going to give you good performance. You can look at the docs.redhat.com under our DM multipath book or document, and it'll show you all of the options that are available for finding multipaths, all the options that are available for path selection, and you can get some good advice here as to what options you want to choose based on your use case. If you just want failover, there's an option for that. If you really want to have the equivalent of link aggregation, there's a section for that as well. So once you've modified your multipath.conf file, you can restart multipath D and then run multipath-ll to see what paths you have enabled. And the way that looks is I've modified my multipath.conf file with those arguments or with those options that I just described. I'm going to restart the multipath D service, and I run multipath-ll, and you can see there are my two LUNs. They're presented as SDB and SDC, and the policy is service time 0. So now it shows me that I've got two paths to my shared storage. Once you do that on your first node, I recommend that you just copy your multipath.conf file and the multipath bindings files to the other nodes. That way it sets all that up for you, and when you restart the multipath service, you're going to have identical path names, and you're going to have an identical policy. So I just SCP'd them across to the other nodes. Very simple. Just configure it once, then copy the configs over. So verify that all the nodes are connected. On each one of the nodes, go ahead and do the iSCSI Atom discovery, do the login, restart the multipath D service, and run multipath-LL. And again, you'll see that your policy is set correctly and the paths are set, so you know you're in good shape. Do that on all of the nodes. On each one of the cluster nodes, use your favorite partitioning tool to create a partition on the empath device. After you've done fdisk or parted or gparted or whatever, you're going to need to either log out and log back in, or just potentially run part probe. So once you've partitioned it, now you've got the multipaths, you've got the partitions set up. Leave it alone. We're going to partition these, or we're going to format the file systems later on once we've got the cluster built. And that's what that looks like. So I fdisk the empath A, set up my partition, and save it, and then log out and log back in. It's fairly straightforward. Just do a -U where we did a -L before. Make sure you do it on both paths, then log back in, and once you've logged back in, you should now have multiple paths to a single LUN, so you're going to be able to have high performance. Now what we need to do is, on each one of the nodes, we need to install whatever the application is that we're going to make highly available. In this case, it's Apache, so I just did yum-y group install web server. And, screenshot, that's what it looks like, yum-y da-da-da-da. It installs the software. Now what we need to do is, we've got Apache, or whatever your service is, installed. Turn it off from an OS perspective. So use checkconfig to turn off HTTPD, because we don't want it to start at boot time. We want the service to be started by the clustering software. So just make sure that you checkconfig HTTPD off. And what you're going to need to do is configure your application to listen on the IP address that you're going to define as that virtual IP address. In this case, I went and I edited the httpd.conf file, and I set the listen stanza, so it says, only listen on the IP address that I'm defining as my floating IP. So in this case, it's 172.31.100.50, whatever number makes sense in your environment, obviously. So I edited it, and then again, I just copy that file across to the other nodes. Fix it once, and then copy it over so that you know all of the config files are consistent. It's turned off. It's not running. We're going to leave it. Now what we need to do is we need to turn on the Riki service on each one of the nodes. So just check config Riki on. Riki requires authentication. The management software is called Lucy. The management interface on the cluster nodes is called Riki. I made a joke one time that it's Lucy and Riki, and we use Conga to do the management interface, and we use the Babalu protocol. And I had this guy came up to me after the presentation. He's like, "Dude, I've been looking on the documentation online. I can't find anything about Babalu." And I'm like, "Sorry, man. It was just a joke. I didn't make that clear. It was just a joke." So what we're going to do is we're going to set the password for the Riki user, check config the Riki service on, and then start that service. And the way that looks is it's fairly straightforward. Password Riki, check config Riki on, service Riki start, and I did that across all three of my cluster nodes. I'm SSH'd into all three of the cluster nodes. So Riki is now listening. Make sure that your firewall ports are opened up and all that kind of good stuff. That the firewall information is in the documentation. On the management console, make sure that you've got the Lucy RPM installed, and I did. Make sure it's check configured on and running, and that's fairly straightforward. Check config Lucy on, and then start the Lucy service. And it will come up and it will generate the private keys, because it's a self-signed SSL certificate, and it'll actually tell you, okay, point your web browser to your host, :8084. It listens on port 8084. Again, make sure that firewall port is open. You're going to fire up your web browser, and because it's a self-signed certificate, you're going to get the old, hey, enter, make sure that this certificate is acceptable. You're going to click the buttons and go through, and then you're going to log on to the web interface. I used the root user to do the configuration. You can actually configure, right? You can configure what user you want, but for sake of this demonstration, I log in as root. And I'm going to get a warning, and I know, again, kind of an eye chart. Basically, the warning says, hey, be careful. This is not a place to play around. Make sure that you know what you're doing because you can shoot yourself in the foot. We will gladly give you the pistol, point to your foot, and go to town, right? It's Linux. You can, there's 10 ways to skin that cat, and 9 of them will involve shooting yourself in the foot. So once you get in, we are going to define the cluster. We're going to give the cluster a name. We're going to define what members or what nodes are going to be members of the cluster. We're going to have an option to tell each one of those nodes just use your locally installed software or download the packages that you need. We're going to have the option to define whether or not we want to reboot. I always do, just because I want to make sure that after the cluster is defined and the cluster config is distributed, that each one of the machines reboots, comes back up, and joins the cluster cleanly. And then do we want to enable shared storage? And that's what this looks like. I'm going to go in, I'm going to choose Manage Clusters, I'm going to choose Create a Cluster, and I'm going to get this screen. And again, I'm sorry guys, I know this is kind of an eye chart, but you're going to put in the cluster name, you're going to define each of the cluster nodes, the password, and it will tell you, okay, I'm going to go to this host on port 1111, or 11111, I'm sorry. I have the option to say, do I want to download packages, use the locally installed packages? So that's an option, it's an either or. And then do I want to reboot the nodes, and do I want to enable shared storage support? In this case, yes, we do want to enable shared storage support. I can also do this from the command line on any one of the nodes. I can log on and use the CCS tool, tell it against host Armitage, create a cluster called Summit, and then add node Armitage, add node Fin, and add node Neuromancer. Once I've done that, I can do CCS-host Armitage, sync the config files, and activate the cluster. Once I do that, I can say start all. Once that's happened, I will have created the cluster. Once I do that, it's going to modify the cluster.conf file. I run the commands, and sure enough, it's created the cluster. There's no nodes in it at this point. Once I say add all these hosts and add all these, and then activate it, it will build my cluster.conf file, which is just an XML file. There are all my clusters defined, and the cluster is now up and running. So I can do a cluster status command, cluestat, and sure enough, boom, 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 they're going to be talking to each other, and you know at this point, your cluster's up. Yes, sir? Not that I know of, no.
Currently, no. That's a Lucy-only feature at this point.
Yeah. So you're going to have to, if you're going to do it from the command line, that's perfectly reasonable, but just make sure you have yum group installed. Okay? So if you've done it from the command line and you want to connect to an existing cluster from Lucy, it's fairly straightforward. When you go into the web UI, instead of choosing create, you're going to choose add. You're going to put in a host name that you want to connect to, and once you connect, it's going to come back and say, oh, I found all of these nodes. Is this what you meant? You're going to say yes, hit the button, and you're going to be able to see the cluster from the web UI. And you can see over here the cluster name. If that little dot next to it is green, your cluster is up, happy, and healthy. We created that multipath block device earlier, so now what we're going to do is we're going to carve it up. I use LVM. I like LVM. I like the flexibility that it offers, so we're going to create a slice for the web service. Now remember, this is a 2 terabyte LUN that I presented. So I'm going to, make sure that I've enabled clustered LVM on each one of the nodes. And the way that I can do that is I look in the etc lvm.conf file, and I see that the locking type is set to 1. That is individual host locking. So I run the command lvmconf -- enable cluster, and it changes the locking type to 3. You can either VI the file or just run the command. So now what I'm going to do is I'm going to do the standard pv create, vg create, lv create. So I do pv create on that multipath device. I do vg create. You need to remember to do vg create -c or clustered. So vg create -c y. Give it a name and tell what block device we're going to. So I created the clustered volume group, VG_cluster. And then I'm going to do LV create. And in this case, I said, well, it's my web server. I'm only going to do 10 gigs. So I do LV create, the size 10 gigs, so --L 10 gigs. The name is going to be LV_Apache, and the volume group that I'm doing it from is VG_cluster. So I created the logical volume. Now what I need to do is, now that the cluster is up, I need to use the command makefs.gfs2. The arguments that you see up here are, I'm going to define the number of journals, because remember, it's a journaled file system. I overallocate. You don't have to, but I overallocate in case I need to add a cluster node later on. So do makefs gfs2-j4. There's only 3 nodes, but I'm making 4 journals. I define the lock protocol, so -p lock_DLM, the distributed lock manager locking protocol. I give it a name. Summit : the first field in the name needs to be the cluster name. So the Summit cluster, the file system is web, and then I give it the path to the logical volume that I'm going to be formatting. So it's going to come back and it's going to say, are you sure? You say yes, and it goes through and you see that it made the 10 gig volume using the lock DLM protocol, and the lock table name is Summit : web, and it also gives it a UUID. So you can add this clustered file system, or you can make this clustered file system available to the nodes a couple of different ways. You can either add it to etcfs tab so that when the cluster nodes come up, they connect to it and it's mounted concurrently on all the nodes. That's perfectly reasonable. If you do that via the file system table, etcfs tab, you just add in the path of the block device, where you want it to be mounted, what the file system type is, and any arguments that you want to pass to it. Obviously, you want RW. I like to do no A time and the related, no dir A time and things like that, because it's going to give you a little bit better performance. I generally put in there _netdev as well, just so that it doesn't try to mount it at boot time. Now, our clustering software is smart enough that it actually doesn't really try to mount it at boot time, but I'm kind of a belt and suspenders kind of guy, so I put netdev in there as well. So once I do that, so I do a df-h and you see that I don't have anything. I do mount-a, and now boom, there is my logical volume, my shared file system that's mounted, and you see that I've got 10 gigs available. So I'll show you how to, instead of doing it through etcfs tab, I'll show you how to do it as a clustered resource. When I first was talking about do I do it through the etcfs tab or do I make it a clustered file system resource, I was like, oh, it's got to be through etcfs tab, right? I mean, the whole point of it is it's concurrent read-write access. That's perfectly reasonable. If you do it as a clustered or as a resource for a service, you're not going to take any performance hit, and it will unmount it from one before it mounts it on the other. If you want to do it that way, that's fine. 6 of one, half a dozen the other. So let's talk about fencing. A fence device is a device that's designed to what we call stoneth, or shoot the other node in the head, to protect your data. You don't want 2 nodes to both think that they own a file system, but not know about the other one, right? Because then you're going to have 2 people write, or 2 systems write into the file system. You're going to clobber each other. It's going to be a bad day for you. We don't like bad days. So it's better to take the other node offline or otherwise isolate it. Fence devices can be things like managed power ports. I like managed power ports. I want to pull the plug on the other node so I know for sure that it's dead. So you can use managed power ports. You can use fiber switch port management, so you can just turn off the fiber switch or the fiber port. SCSI reservations, HP ILO, Dell DRAC, IBM RSA, etc. For this presentation, we're going to use a WTI power switch. WTI is awesome. You can get them for a very, very inexpensive price. They're very smart. They're super reliable. I like them, but all the other ones are viable options. So if you want to define your fence device from the web UI, it looks like this. You're going to go into the cluster, go to fence devices, click on add. You're going to have a drop down here. I chose the WTI power switch. You're going to give it a friendly name, the IP address or host name, what the login is, what the password is. If you have any other commands that you want to run, you can put those in there. The one thing that I kind of found out accidentally you really probably want to have is there's a power wait section, which the power wait section is if you're going to flip a power port on and off, how long do you want to wait after you turn it off before you turn it back on? I forgot to set this one time, and I rebooted a node, and it goes tick, tick. Ooh, yeah. The system came back up and goes, we've got a power failure, the BIOS is hosed, and yeah, you don't want that. So set some sort of a power wait timeout in there. So once you've done that, yeah, I know, you've been through that, right? I'm hearing a guy laughing up front. He's like, no, that's not good. So once it's done, it's going to show up in the web UI, and you're going to notice over here that the number of systems which are using this fence device is set at 0. So what we need to do now is we need to go back on a host-by-host basis and tell the clustering software which power port that host is connected to. And the way that we do that is we go back to the Nodes tab, click on a node, go down here under fence devices and say add a fence method. I defined the method with just the friendly name power. So I'm going to add a power fencing method. Once I define that power fencing method, I'm going to say add a instance. I click on that button. There's going to be a drop down that has that WTI power switch, and I'm going to say, okay, this machine is connected to power port number 4. So now if one of the other nodes needs to turn him off, they know to log into the fence device, turn off power port number 4. Okay? Lather, rinse, and repeat for each of the nodes. There's the fence device. This guy is on 3. Add a power device to the next node. So I'm sorry, let me go back. I selected... First I did Armitage, now I'm doing Fin, I add the same information, and now I'm doing Armitage, or Neuromancer, I'm sorry, power device, this device, and port number 1. So now we go back and we see that there are now 3 nodes that are using this fence device. So now all of the nodes know which the other node is connected to, and they can shoot the other node in the head. You can also go over here on the configuration tab in Fence Daemon, you can also set delays. Like if you have a post-fail delay, or if you want to define a post-fail delay, like let's say, oh, I've got a system that's kernel panicked. I don't want to just immediately power cycle it because I want to do a kernel dump and capture it. Define how long you want the delay to be for that kernel dump to complete, or for whatever reason you wanted to have a power delay. Now we can do exactly the same thing that you just saw me do from the web UI, from the command line. And again, these slides will be available on the Summit website, but the syntax is pretty simple. You use CCH, connect to one of the nodes, say add method power to the server called Armitage. So I've added the method, and now I actually create the fencing device here. So CCS, add fence dev WTI, put the agent fence WTI, the IP address, the login, the password, and the power wait. And then I associate each one of the nodes. So CCS add fence instance WTI to the host called Armitage. The power port is 4. Do the same thing over here to Fin. Power port is 2. Same thing to Neuromancer. Power port is 1. So from the command line or from the web UI, the net result is your your cluster.conf file will be modified. There's all my power information, and each one of the nodes now has a power port associated with it. All right, so I can also add that fence delay, that post-fail delay. I can do CCS-H Armitage, set fence daemon post-fail delay equals 5, and it will then add that to that XML file. Yes?
I just had one quick comment. Post-fail delay was previously very commonly used for allowing a host to wait prior to completing a dump. As of Red Hat Enterprise Linux 6.2, we actually have integration with our KDump environment, so you can delay until dumping is complete, but prior to power cycling the host. So,
if you have a kernel panic, yeah, when the KDump kernel loads, it's actually going to know that it's part of a fenced environment?
Yeah,
or
actually, what will happen?
Oh no, it'll happen on the other nodes.
Yeah. So what will happen is the KDump environment is entered, and the cluster immediately says, "Okay, we're done." That node's dumping. We know it's in a safe state. The cluster can then continue. It doesn't have to power cycle it.
Very cool. I just learned something. See, that's why I love having him here. I'm just the pretty face. He's the brains. So let's talk about failover domains. A failover domain is just a logical grouping of how you want services to run on the nodes. So when you define a failover domain, you're going to give each node which is in the failover domain a priority. Kind of like the way nice priorities, the lower the number, the higher the priority. When you define a failover domain and you assign a host to that failover domain, the lower number means the more likely that a service which is running in that failover domain is going to run on that node. And I'll show you what I mean. So you create a failover domain for each service you define, or for each group of systems that you define. From the web UI, you go in, and now we're on the third tab. You go to failover domains, click on add. Give it a name. Like I did prefer_Armitage. I'm going to create a failover domain that says any service that's running in this failover domain is going to start on Armitage first. I check the box that says prioritize. That's what allows me to give these values over here. I check the box that says restricted, which means that any service that's running in this failover domain is only going to run in this failover domain. There is an option to check the box that says no failback. By default, if you define a failover domain and assign priorities, and a service is running on a node and that node fails, The service is going to migrate over to another node until that node with the lower priority comes back, and then that service is actually going to fail back. You may not want that to happen, because essentially you're going to take a small outage when that service migrates back. So up to you, up to your environment as to whether or not you set no failback. Once I've done that, I'm going to check the box next to each server I want to be a member of the failover domain, and I'm going to assign it a priority. Since this is the prefer Armitage failover domain, I give Armitage a low number, 1. And then I say, yeah, my next one's going to be Finn, so I give him 10, and then my next one's going to be Neuromancer, and so I give him a 20. So any service that runs in this failover domain is going to start on Armitage first, then it's going to fail over to Finn, then it's going to fail over to Neuromancer. I've defined it for prefer Armitage. If I wanted to, in this example, I did the same thing for prefer Finn, where I gave Finn a lower priority, then Neuromancer, then Armitage, and then I created one for prefer Neuromancer, which is going to give Neuromancer the lowest, then Armitage, then Finn. So I've kind of created a round-robin type of effect for my failover domains. So they're defined, they're all set up. I don't have any services running on them yet. If I wanted to do the same thing from the command line, I'm not going to go into every single line, but suffice it to say, again, you can script all of this using the command line, and that's the syntax. I'm not going to go over all of it right now because I know you can't see it because this projector is not very good. But suffice it to say, there are command lines to do all those. When you get done, the XML file looks like that. I've defined all my failover domains, I've defined the members and what their priority are. So, let's talk about resources that we're going to make available for a clustered service. First, we'll start with the GFS2 file system. Remember what I said earlier. It can either be in etcfs tab or be defined as a resource. Don't do both. That would be a bad thing. I think you confuse the cluster at that point. If you want it to be available on one host, you can define it as a resource to be used by a service. And the way that we do that is, and you notice we're just kind of going to the right across this. It's almost wizard-like in that you start on tab 1, then tab 2, then tab 3, then tab 4. Anyone do clustering with rel 5? Yeah, it wasn't so much wizardish, was it? Yeah, there was a little more brain sweat involved in that one. What's that? Beating your head against the wall-ish. Yeah, hey, come on. It wasn't that bad. All right, so we're going to go to the Resources tab. We're going to choose Add. We're going to define the resource. There's a drop-down, and in this case, I chose the GFS2 service. I'm going to give it a name. I called it WebGFS. You can call it whatever you want. That's a friendly name. Where am I going to mount it? My mount point, I did var www.html. What the block device is, the device file system label or UUID, and I did /dev/mapper/ and then I gave it that logical volume. What the file system type is. If I want to pass any arguments to it, I did no A time again. And then down here, there's a checkbox for force unmount. If you use force unmount, then what will happen is, as the service migrates, it'll unmount that file system from the node from which it is migrating before it mounts it on the node to which it is migrating. If you don't do that, it'll leave the GFS file system mounted because there's no reason to unmount it. So again, depending on your use case, you can either check that box or not. And then there's another one that says reboot the host if the unmount fails. So if you really want to absolutely positively make sure it's unmounted, like let's say instead of using GFS2 we're using ext4 and high availability LVM, you don't want multiple nodes mounting an ext4 file system. Very bad things will happen and you will have a bad day. And the whole point of today is for you not to have bad days going forward. So if you want to make sure that gets rebooted, you can check that box. So now we've got a resource defined that's a GFS2 resource. We're not doing anything with it. We're just setting the stage for the clustered service. Now what we're going to do is we're going to go and add another resource. So I go to Resources, click on Add, and we're going to add the IP address. And this is fairly straightforward. Once we've clicked on Add, we do the drop down and say it's going to be an IP address. We put in the address. Don't put in the net mask. It's going to know what the local net mask is, and it's going to use that. The only time you'd use the net mask is if you were doing a different network, right? A different subnet.
Yeah, and so typically the net mask is actually not used. So
yeah, so don't do it. I did it, and it caused all kinds of wonky behavior. You don't need to. It's smart enough to figure out what you're talking about. And then there's a checkbox that says monitor the link. So if the link goes down, it'll restart that resource. Excuse me. Let's see. And there's also a sleep section here. How long do you want to wait before we've downed that interface, before we consider it to be downed? The default is like 10 seconds.
Yep. So that's allowing the kernel to settle basically for this service, you could set it to 0.
I set it to 1 just and go, well, I'll give it a second or so, but 10 seconds is way too long for this particular service. So once we've done that, it shows up as a resource. Again, we're not using that resource yet, but we've now defined it. We're going to add one more resource. In this case, it's the start-stop script for Apache. This can be any start-stop script. I just happen to do Apache. So I click on Add. I drop down to Script. I give it a name. I called it Apache script. It's not terribly imaginative, but it is intuitive. And then I just give it the path to the init script, rc.d, init.d, httpd. So once I've done that, I now have 3 resources defined. They're not doing anything yet. I've just made these resources available for defining a service. I can do all of these from the command line as well. Like I said, if you want to do this from the command line, you can, and that's the syntax for it. Again, I'm not going to go over every single one of them except to say you can add resource cluster fs. There's the path. There's the force unmount. There's the file system type. So it's fairly intuitive. Well, I don't know about intuitive. It's a big honkin' ugly command line argument. But once you've done it a couple of times, it's like, oh yeah, that makes perfect sense, right? And then once I've done that, that's where it adds it into the cluster.conf. And then I do the same thing with the add resource IP address, add resource script, and you see down here in the bottom, there are my 2 resources that have been added to the cluster.conf file. Okay? All right, now we're going to tie all of this together. We've defined the resources. Now let's add those resources to a service, a clustered service. From the web UI, you're going to go in. Now we're just over to the next tab. We're going to go to the service groups, click on Add. I'm going to add in this case, the web service. I've got a checkbox that says automatically start this service. When the cluster comes up, do I want to start the service automatically? For this, yes. You may have an environment where you want to bring the cluster up and make sure that it's ready to go, but don't start the service until you trigger it. So I'm going to check that box. I'm going to say what the failover domain is that I'm going to run this service in. I choose prefer Armitage, and I'm going to set a recovery policy. It can restart, it can fail and migrate, it can do a number of different things. I chose restart. If the web server crashes, I want it to restart, but I only want to do it 3 times in 600 seconds. So if the web service fails 3 times in 10 minutes, something is wrong, migrate it over to another node. Make sense? All right. So I'm going to add that resource to the service, and now I'm going to add I'm going to choose add a resource. It's going to give me the option of what resources I want to add. I chose the GFS2 resource, and boom, it's there. Notice it's grayed out because we've already defined it. We don't want to make changes to it. I'm going to scroll down. I'm going to choose add another resource, and when I add the next one, you'll see that I've got my IP address resource. It's all grayed out because we've already defined it. I'm going to scroll down. I'm going to choose one more resource, and when I do that, I'm going to have my script resource. So I've defined the service. I'm going to say add the IP address, the file system, and the script. When I get done, there is my web service. And the cool thing is, I was capturing screenshots for this. By the time the screen returned, the service was up and running. My web server was up and running, and we were in good shape. And you can see that the web service is up. It's running on the server called Armitage. Now, one thing to know is we actually have built-in logic. I mean, we understand that you've got to have a file system before you can run a service on it, right? And you've got to have an IP address before you can run a network-facing service. So you may have noticed in the screenshots, you have the ability to set parent-child relationships. In this case, for a simple service, not necessary. Our code is smart enough to figure that out. If you want to do it, there's nothing wrong with that. And if you have a complex service where you've got to have some sort of listener before you bring the database up, you got to have that before you bring the web server up, that's perfectly reasonable. You can do that. It's not strictly necessary on a Red Hat provided service. By the way, sir, you can absolutely take pictures of the screen, but this presentation is going to be available at the end of Summit. It's going to be posted in its entirety on PDF. So take pictures all you want. You're perfectly welcome to do so, but you're going to get the whole thing. So the same thing can, again, be done from the command line. I'm not going to go over all of the syntax except to say, first we're going to add the service, then we're going to add then we're going to add a subservice, which is the web server IP. We're going to add subservice web service to web service, which is the script resource. We're going to add a subservice, which is the cluster file system. I'm going to sync and activate it and make sure I start it all. It's going to go out and say started on Armitage, started on Neuromancer, started on Fin. you can actually look in var log messages on Armitage. You can see it jumping through all the hoops. I'm mounting the file system. I'm bringing the IP address up. I'm executing src.d and init.d HTTPD, and boom, the web service is started. So you can do it from the command line, or you can do it from the web UI. And sure enough, over on Armitage, I see that my web server is running. And when I run clustat, cluster status, I can see all my nodes are online, and the service, web-service, is running on Armitage, and it is started. So now that we've got it up and running, we've defined our highly available web service. Let's test it. Let's make sure that it's doing the things that we expect it to. So first, let's do a migration. Let's just make sure that the cluster understands how to move the service from one system to the other. So I'm going to go into the Service Groups tab. I'm going to click on the web service. I've got a drop-down here that says, currently it's running on Armitage. I click the drop-down and say, hey, go put it onto Fin. And I hit the button over here that looks like the play button on a DVD player or something. I hit that button. After a couple of seconds, I'm going to get this pop-up that says, yep, it moved over to Fin. And sure enough, I'm going to see that it's now running on well, right now it says running on Armitage, but it'll actually, that screen will change and say it's running on Fin. To do that migration from the command line, it's fairly straightforward. Clue Service Admin, Cluster Service Administrative Tool, relocate the service web service and migrate it to the machine called Fin. You'll see it saying, I'm trying to relocate the service. If you look at var log messages over on Fin, you'll see it saying, I'm mounting the file system, I am bringing up the service, bringing up the IP address right there, executing the script, and boom, the service is started over on Fin. And then you're going to get a return back over here on your Clue Service Atom command saying, yep, we migrated, we're good. So the IP address starts, the file system is mounted, and the service starts. So what happens if we crash it? What I did was, not terribly elegant, but I'm on the machine on Fin, because remember we migrated it over to Fin, and I run pkill-9 HTTPD. Boom! After a couple of seconds, you'll see, where'd it go? It says executing HTTPD status. Uh-oh, it returned to 1. So the status is failed. I'm going to stop the service. So it shuts down the web server, removes the IP address, and then it says, I'm recovering the failed service, I'm adding the IP address, and I'm executing HTTPD start. Boom, it's back up. It'll do a service HTTPD status every 60 seconds. And sure enough, my HTTPD service is running again, so I'm going to pkill it again. And then I'm going to pkill it again. There was a 1-minute gap between each one of these. So shoot it. After the third time, because remember we set that threshold, 3 failures in 600 seconds, you're going to see it's going to come down and say, oh, return to 1, it's a generic error. I'm stopping it. I do HTTPD stop. I withdraw the IP address. And hey, man, this thing has failed too many times. The restart threshold has been exceeded. I'm relocating it. And now, sure enough, you'll see it says now it's running on member 1. Remember we set priorities, so it failed back to the machine with the lowest priority in the failover domain. And if I run clustat from the command line, service web service is running on Armitage and it is started. So we've crashed the service. What if we crash a host? So what I did was I logged on to Armitage and I echoed C to /proc/sysrec trigger. That triggers a kernel crash. And I mean, it crashed. I hosed the machine, threw an error onto the screen, down it goes. Now, over on Fin says, ooh, a processor has failed. Over on Armitage, on Neuromancer, Neuromancer says, ooh, yep, a processor has failed. We're going to form a new configuration. Neuromancer just happens to say, I'm going to defer fencing over to Fin. And over on Fin, if I look at var log messages, you'll see that it says, where to go? Fencing node armitage.tc.redhat.com. So Fin at this point, the two of them said, hey, is he down? Yeah, he's down. Okay. Neuromancer says, hey, Fin, fence him. Fin logs into the WTI power switch, pulls the plug, the port number that we defined, kills the machine, and then on Fin, you're going to see it fences the node, it replays the journal, it brings up the GFS file system, it adds the IP address, executes the script, and boom, the web service script is started on Fin. Now, when I run cluster status, I'm going to see this guy is offline, but it's okay, the service has started on Fin. We're in good shape there. I kind of wasn't paying attention. I left a shell open, and I was running tail-f varlog messages on Fin, and all of a sudden I started seeing all this activity, and I looked over at it, and I realized, oh yeah, that's right. The other node came back up. Armitage is back up. So we shut down the HTTPD service, stop the script, withdraw the IP address, and the service is stopped on Fin. And then it restarts again over on Armitage because we didn't check that box that said no failback. So be aware, if you check the box that says no failback, it is going to fail it back. So, man, 0 to cluster in 60 minutes. Those are the steps that you need to take to bring a simple cluster up. I've written this so that you can do this on a couple of machines in your office. They can be desktop class machines. The goal of today's presentation, certainly not to make you walk out of here and get the same thing that you would out of a 5-day training course with Red Hat Global Learning Services, but this should give you the familiarity to start playing around with this in your environment. This is actually pretty much, even though it's on desktop class hardware, this is an enterprise configuration, man. You got iSCSI, you've got multipath set up, you've set up the load balancing on multipath, you've set up all the cluster, you've set up all the resources, so you should at this point be able to go out and bang on this in your environment. As an appendix to this deck, there are 2 shell scripts that I use to build and destroy my cluster at my website, people.redhat.com/tcameron. If you go look in the section for Summit 2012, there's actually 2 shell scripts. One's called down cluster and one's called up cluster. You can see everything that we did today from the command line in those shell scripts, and you can build this literally in an afternoon. Good way to get familiar with it. I hope that this has been helpful. If you like today's presentation, please fill out the evaluation form. That is actually kind of important to those of us who do the presentations. If you didn't like today's presentation, fill out your evaluation form and bring it to me. I'll take care of it. Are there any questions? Yes, sir. Different fencing methods for different nodes in the cluster.
Yes, although it's not typically done.
Yeah.
So, for example, typically you don't, for example, set up a storage-based fencing solution in conjunction for one node and then power on the other node. Usually it's power and power, but the devices are not always the same. For example, if you're using HP integrated lights out, each device will correspond to exactly one host. Does that answer your question?
So you can, but don't. Yes, sir. Mm-hmm.
Okay. So the question is, what is the technical difference between using a script resource versus using the canned resource agents that we provide? The resource agents are designed for cases where you need multiple instances of some type of resource in a cluster. So IP addresses, typically you'll have more than one IP address, whereas if you had to do that with a script, there's no way to tell the script that, what the IP address is. So the resource agents provide ways to pass in parameters from the cluster configuration to the resource agent itself. The script it's just kind of a wrapper that allows you to use existing services, but there's no, typically the short answer is that if you're using a resource agent, it should allow you to more easily configure multiple instances of, for example, Apache or Oracle databases or MySQL databases, that sort of thing. Whereas if it's a script, you're going to have to, make copies of the script and use different scripts to start each instance separately. Yes. Yes, the question is, can you, for example, insert a web service directly? Yes, you can. We have an agent that controls Apache. We used the script resource in this presentation because it's familiar, it's simple, and you can use it with anything. And anything that follows LSB standards. Yeah.
Hey, real quickly, if you were doing the Summit Cup thing, the Summit Cup game check-in code for this session is 1988. And before everyone starts running out, please continue to ask questions, but I just want to say very briefly, on behalf of Red Hat, thank you very much for coming. We do appreciate you being here. On behalf of Lon and myself, Thank you for giving us the opportunity to come talk to you today. Any other questions, please continue on, but otherwise, thank you for coming.